Hi everyone, today we're going to talk about sections 9.2 and 9.3. This first page of notes is talking about 9.2, so that says inconsistent and dependent systems. I'm not really going to be using that terminology. I'm going to talk about no solution and infinitely many solutions, which is kind of like what we've talked about before. So if we look at our first system here, if I want to set up the augmented matrix, okay, we're going to be using our calculator here. So our augmented matrix, just a reminder, is our coefficients. So I've got 1, -1, -2. Got a line down the middle, and then we put the constant on the other side. And we do the same thing for the second row and the third row. Okay, all right. So this is what we're going to be typing into our calculator as a matrix. So let's see if I can fit these both here. Okay, so I'm going to go into the matrix menu, go over to edit, and we're going to edit matrix A. Now notice that this is 3 rows and 4 columns. So we're going to have 3 by 4. So I'm ready to type the numbers into the calculator. Okay. All right, so now we have all of the numbers typed in. If you want to pause the video, give yourself a minute to type those in. That's fine too, but I'm just going to keep going here. So I'm going to second quit out of here, and we need to go to the RREF option under Matrix, Math, and then I went all the way down to RREF. So now we're going to type the matrix in. So we have to go back into the matrix menu. So second matrix, and I'm ready to put in matrix A. Okay, so now I'm going to, normally I wouldn't write this whole thing out, but I just want to show you guys what it all actually means. So I'm going to write it out over to the left here. So what we end up with, we're going to write solution here. Okay, so I'm just going to copy out what the calculator gives me. Okay, so get those constants in there. All right. Now what we want to be looking for here is this bottom row. Anytime you see something like this, okay? This matrix that we were typing in, remember that the first column was all of my x's. So I'm gonna put x here. My second column was all my y's, and my third column was all the z's, right? So what that tells me is that when I have 0x plus 0y plus 0z, it's going to equal 1. Remember, that was the constant, so that's what we just came up with. Now, if I simplify that, I get 0 is equal to 1. Now, we've seen in previous systems that if you use elimination or substitution and you get something that is not true, this would be considered no solution. So really what you're looking at in the calculator is just the fact that you have 0 on the left side is equal to 1, which is an untrue statement, okay? So I'm gonna have you guys take a minute and type the next system into your calculator. After you hit the unpause button, I will put the augmented matrix and the solution matrix here and we'll talk about it. Go ahead and pause the video. All right, so now we have the augmented matrix here. I typed it into my calculator. I did the RREF matrix A. That was the matrix I typed it in as. And I ended up with this answer. So remember that the first number is your x, that's your y, that's your z, and it's equal to the constant. So here I have 0x plus 0y plus 0z is equal to 0. Well, that means we have 0 equals 0, right? Now, this is a true statement. I didn't solve for any variables, but I got an equation that was true regardless of what x, y, and z I put in there. So this means you're going to have infinitely many solutions. So again, it's this bottom row that we're looking at, and we're using that to come up with an equation. This row potentially could be elsewhere. It could be in the middle, but generally you're not going to see it written that way. It'll end up in the calculator on the bottom, okay? Now the last one, we actually don't even need to use our calculator. And the reason is, you'll notice that you have 3 variables, but only 2 equations. 3 variables, oops, but only 2 equations. So if you did have 3 variables, this is going to require 3 equations to solve. So we're going to say this one is also going to be no solution. Okay. So we'll just say here, no solution. Okay. There is a method of finding expressions for the variables, but for our purposes, as soon as you see 3 variables and only 2 equations, we know that it's not going to work. So go ahead and write no solution. Okay. So that pretty much wraps up 9.2. There's not really a whole lot going on there. Let's go ahead and jump to matrix operations. So the first part of this is adding and subtracting matrices. And what we're going to be doing here is just add or subtract corresponding entries. Now, we can only add or subtract matrices if they have the same dimensions. Notice these are both 2 by 2. These are both 2 by 2. We have a problem with this last one. Notice the first matrix is 2 by 2. This one has 2 rows and 1 column. So we cannot add. So we don't even need to worry about that last one. Now, looking at our first example, addition means I'm going to add the corresponding entries. If I'm looking at the top left, I add it to the top left, and that gives me 10. Now I'm going to move to top right, add these together, I get -4. Moving down to the bottom left, I get 10. And finally, bottom right, I get -1. Okay, so we're just adding up the corresponding entries. Subtraction is the same thing. You always have to be more careful with subtraction because of the negative sign. So I've got 8 minus 2, which is 6. 3 minus -7. So that actually turns it into a plus 7. What you could do here is actually change this to a plus and then change all of the signs to be the opposite. That actually makes it a little bit easier. You don't have to worry so much about the subtraction. You're now switching it to addition. So now I've got 10. 4 plus -6 is -2. 0 plus 1 is 1. Okay. So our next type of problem is multiplying a matrix by a scalar. A scalar is just a number, okay, a real number sitting in the front. And essentially what we're doing here is we're distributing, okay? So you're multiplying each entry by the scalar, and that's it. okay? So let's go ahead and do this first one together. So I've got 3 times -2, 3 times 0, 3 times 4, and 3 times -7. Okay, and that's all there is to it. Okay, now you could have a combination of multiplication and addition, subtraction, all sorts of things. Order of operations will still hold true. When you're simplifying. So that means you have to do this multiplication first, and then you can do the addition, okay? I want you guys to go ahead and pause the video for a minute and try letters E and F, and when you unpause, the solutions will be up. Go ahead and check out the solutions. So you'll notice in letter E, we distributed first into the first matrix, and then we added our corresponding entries. Likewise over here, I multiplied H, everything by 5, and then I added the corresponding entries. Okay, so the final solutions are in the boxed highlighted section. Okay. Now, the next part of this is, well, let's use our operations to solve an equation. So let's say we have an equation, 2 times matrix X, which is our variable matrix, plus matrix A is equal to B. And you'll notice the matrices are written over here. So I'm going to plug everything in. So I've got 2x plus, oh, I should draw that a little lower. Got 1, -5, 0, 2. And that's equal to matrix B. So we've got -6, 5, 9, and 1. So it's just like solving an actual equation where I need to get our variable by itself. So I need to subtract this matrix. So I'm just going to write minus A. I'm going to write minus 1, -5, 0, and 2. Okay, so really what we did was we just canceled this out. And I'm going to change the subtraction to plus and change all those signs, just so we're distributing that negative through. So now I've got 2x is equal to, so -6 plus -1, 5 plus 5 is 10, 9 minus 0 is 9, 1 minus 2 is -1. And if you look at this equation, really what we want to do is divide everything by 2. That means we're dividing every single term by 2. So I have -7 divided by 2, 10 divided by 2, 9 divided by 2, and -1 divided by 2. So our final answer, oops, fell off the screen here, is over here. Okay. Well, what if we have, instead of a big X like this as a variable matrix, what if we have variables within the matrices? Well, our process is still going to be similar in that we're solving the equation. So remember that when we're solving, you want to combine the stuff in the parentheses first. So I've got 2 times. Now, when I add these two together, notice I've got 3x plus 4. Those are not like terms. So I have to write it as 3x plus 4. That is the entire first entry. Now, when I add these two, I've got -1 plus 1 is 0. That goes over here. 8 plus -2 is 6. 5 plus -y is 5 minus y. Okay, now we know that that's equal to the right-hand side. We can't do anything there. Okay, our next step is to distribute what we have over here. So I'm going to go ahead and pause the video and you guys can distribute. All right, so we went ahead and distributed 2 times everything inside this matrix. So you just double all of the items. So I end up with 6x plus 8, 12 on the bottom, 0 on top, 10 minus 2y on bottom. Okay, now one thing I want you guys to notice is that the top right is equal to the top right. That's good. That's what we're looking for, okay? Bottom left is equal to the bottom left. Great, we know that they have to be equal to each other. Now, I know that 6x plus 8 has to equal 26 because the top left entry has to equal the top left entry. So we just set them equal to each other. Solving gives me x equals 3. Okay, now I also know that the bottom right has to equal 8. And so when I solve, I get y equals 1. So I was able to solve for my variables just by setting the corresponding entries equal to each other. Okay. Now, what this is all leading us to is finally matrix multiplication. Okay. And actually, now that I think of it, I think I might. Oh, the video got cut off for some reason. Okay, so we've got matrix multiplication. So the thing with matrix multiplication is that you don't multiply the matrices by multiplying corresponding entries. This is not like addition. It's not like subtraction. It's way different. So I'm going to show you guys a trick that helps me to multiply. So the key is that you want to underline the rows in the first matrix and circle the columns of the second. I think this method is usually the easier way for me to go about it. So I'm going to go ahead and do that in the first one. So underline the rows, circle the columns. Okay. Now the way that we set this up, you'll notice that I have the products written over here. So notice it's A times E plus B times G. And that goes in the first space. Now, an easier way for us to look at this, I'm actually going to draw our product matrix. And I'm drawing it really big here. You can notice that it's kind of huge. And I'm doing that intentionally just so you guys can see what's going on. So my product, if you've got 2 matrices that are the same size, your product is also going to be the same size. Okay, so I will show you another way once we get to some different types of matrices. But these are easier because 2 by 2, 2 by 2, this one's going to be 2 by 2. Now, I like to label, at least when I'm first learning how to do this. This one's in the first row and in the first column. Notice that's the position of this entry. My second entry is the first row, my second column. Down here, I'm in the second row and the first column. And here, I'm in the second row and the second column. Now, I like to use this to tell me which parts to multiply. So I'm going to choose my first row and my first column for this first space. So you're always going to multiply 2 times 0 and add it to 3 times 5. So it's like you're taking the product of the first 2 numbers, the product of the second 2 numbers, and adding them together. Let's do the second one. So I'm going to use the first row, and now we're using the second column. So I've got 2 times 1 plus 3 times 6. Excuse me. All right, now we're down to the second row and the first column. So I've got 4 times 0 plus 7 times 5. 4 times 0, 7 times 5. And now second row, second column, 4 times 1, 7 times 6. And the last thing we would have to do is just simplify all of those products. So I've got 0 plus 15 is 15. 2 plus 18 is 20. 0 plus 35. 4 plus 42 is 44. And this is our final answer. Okay. So on a quiz, if I were to have you guys show your work for something like this, let's say if it was multiple choice, you would get a point for having the correct multiple choice. Obviously, you could do it in the calculator, but if you didn't show the work, you wouldn't get the points. Okay, so this work is showing that you know what to multiply and where. Okay, now what if we have two matrices that aren't the same size? Now the key is that you can only multiply two matrices. Notice the first one's a 2 by 2, the second one's a 2 by 4, 2 rows, 4 columns. You can only multiply if the middle numbers are the same. That is the only way it's going to work. So middle numbers in dimensions are the same. That means the number of columns in the first matrix is equal to the number of rows in the second matrix, okay? So in this case, these are the same, they're both 2, so it is gonna work. Now our process is gonna be real similar, and what happens is the numbers on the outside give you the dimensions, okay? Numbers on outside give dimensions of the product matrix. Okay. There we go. So we know we're going to have a 2 by 4 matrix. That means 2 rows, 4 columns. So if I were to set up, again, I always like to do this really big. 1, 2, 3, 4. 2 rows, 4 columns. There we go. Okay. And so now I'm going to underline the rows in the first matrix and circle the columns. I'm going to go ahead and pause the video and you guys can see if you can try to multiply. If you'd rather just watch me do it, I'll go ahead and do that on video. That was the first row, first column. Now I'm in the first row, still using this top row, second column. Now I'm still using the first row and the third column. And finally, first row, fourth column. And now we're ready to go to the second row, first column. If it's easy enough for you to multiply in your head, let's say over here I've got 1 times 2 is 2, plus 3 times 2 is 6. It is a little bit easier. You don't have to write down as much. I would totally accept this as work. Using my third column, 1 times 3 is 3, plus 3 times -1 is -3. Finally, bottom row, last column, 4 plus 18. And at this point, we can simplify all of our values. I've got 4, let's see, 8 plus 4 is 12. 12 minus 2 is 10. 16 plus 12 is 28. Finally, 1, 8, 0, and 22. And we have our final answer. Okay. Now our very last couple problems, I've got a 1 by 3, 1 row, 3 columns, or 3 columns. Here's a 3 by 1, 3 rows, 1 column. Now I am able to multiply A times B because it's a 1 by 3 times a 3 by 1. Notice that the inside numbers are the same. Okay, and the product is going to be a 1 by 1 matrix, just a single number. Okay, reason being, I'm going to take all these numbers in the row and multiply by the column. Okay, so I would end up with 1 times 4 plus 2 times 5 plus 3 times 6. And really that's all there is because we only have 1 row, we only have 1 column. So that gives me 4, 14, 32. And that would be our final answer. Now, as a challenge, I want you guys to see what happens if you flip the order. Okay, I will post the worked out solution for this last one in the notes, but go ahead and give it a try. That wraps things up for today's lesson. Go ahead and work on the homework and call in during office hours if you have any questions. Thanks, have a great day.